Hello dear students, we are going to solve this one past paper question. This question says that nitrogen 2 oxide reacts with hydrogen as shown in the following equation. So they have given this equation and they have given the table. And the table they have given table they have conducted 4 experiments and they have given the concentration of NO and H2 and they have given the initial rate of the of N2. So form N2 is formed. So in that way they have given this whole equation. So let's find out. In order to find the order of reaction with respect to NO, we have to find the concentration of the other one, that is H2, to be constant. So we can see where H2 is constant. So in experiment number 1 and experiment number 3, you can see it is same value, 0.100 and 0.100. So this is constant. So we can find for NO, because NO is changing and H2 is constant. So this we can find easily for this from experiment 1 and 2. So we will find order with respect to NO. So let's take the value. So in experiment 3 it is 0.2 and in experiment 1 NO was 0.1. So we will take 0.2 in the numerator, 0.200, this value in the numerator, and this value in the denominator, 0.100. So we will get the answer as 2. That means concentration is doubled. Concentration is doubled. So when concentration is doubled, so this is for concentration we found for NO. So what happens to the rate? Now same experiment 1 and 3 we will find for same thing. We will divide and we will get the rate. But the thing is that here you should remember that the values they have given here are actually first and second experiment they have given 10⁻⁶ here, and here 10⁻⁶, and others are 10⁻⁵. So it's always desirable to convert it into same scientific notation. So we will convert it into same scientific notation. We will make it first and second experiment to 10⁻⁵. So here 253 into 10⁻⁶ they have given. So what we can do, it is 2.53 into 10⁻⁶. So we will do is what now? We will shift the points. So if we want to shift the points, it is 2.53 into 10⁻⁶, and we want to make it into 10⁻⁵. So what we have to do, when we are taking the this decimal to the left side, then it will become 10 from 10⁻⁶ to 10⁵. So what it will become? It will become 0.253 into 10⁻⁶. So -5. So this is the value what we want. So this value we will consider as this. Now even this also 5.05 into 10⁻⁶. We will convert it into something that will be 10⁻⁵. So for this also we will shift towards the left side. So it is 5.05 into 10⁻⁶. So it will become because we are shifting it. So the point will move towards the left. It will become 0.505 into 10⁻⁵. So these two values, now all the 4 values are in the same scientific notation, 10⁻⁵. Now I have rewritten the rates in 10⁻⁵. Everything is in 10⁻⁵. So here we can now solve this question, and we are considering experiment 1 and 3. So this experiment 1, this one, and third one is this. So these two we will take. So we will divide the this higher number, means 1.0 into 10⁻⁵. This one. Okay, this one we will divide with this. So we will keep it in the numerator. So for the rate, we are finding for the rate 1.01 into 10⁻⁵ upon 0.253 into 10⁻⁵. So minus 10⁻⁵ minus 5 will go. So let's solve in the calculator. We will get answer as 4. So here rate. Now rate, here rate, and here concentration is given. So you can see here it was 2, concentration was 2, and rate became 4. So as you can see the concentration is 2 and rate is becoming 4. So that means we can say like 4 by 2. So 2 on the 2, 2 to the 4. So it means that it is second order with respect to NO. And concentration and rate are same, like we get the value of concentration as 2 and rate also 2, then that will be first order. But here concentration here is doubled and that became quadrupled, that rate became 4 times, means 2 to the 4. So it becomes 4 times. That type of reaction is actually second order reaction. So I will explain you that also. Always remember, like concentration is given. So for zero order, okay. So for zero order there will be no change at all. And for first order, if concentration doubles, rate also doubles. Means both the values will be same. Like if we get concentration, this value, what I have discussed here as 2, and this also as 2, rate also as 2, then that means it is first order. If same value we are getting, then it is same, then it is first order. But here what happened here, what we have done here, we got the concentration 2 and the rate became 4 times, 4, so that means quadrupled. So here 4 times it has become. So that's why it is second order. This reaction is second order reaction. So this you should remember. But as respectively, if concentration triples, this also you remember, triples. For zero order there will be no change at all. But here rate triples. Here rate triples in the first order as it is. Concentration triples, rate also triples. So rate triples. And here and for second order the rate becomes 9 times. The rate becomes 9 times. Tripling the concentration, rate becomes 9 times. Okay. And for if you are increasing the concentration 4 times, okay, 4 times, then for zero order there will be no change, and it will for first order it will be same as concentration 4 times, but here it will be between 16 times. So it will become 16 times. So this you remember, this is the table, and our what we got here 2 and 4 now. So here concentration is 2 and rate is 4. So for this it is matching with doubles, means it was 2 and here it became quadrupled into 4. So that's why it is second order reaction. We got the answer as second order reaction. Okay. So thank you for watching this till here. Now we will solve the next part. Okay. As we have done for NO, keeping H2 constant, so we have to do similar thing by keeping our NO constant and H2 doubling or tripling. So let's find out and we will solve this. Okay. Now they have asked order with respect to H2, so we have to keep NO constant. So for this now we have to choose a value where NO is same. So experimental value where NO is same. So let's see what we can choose. So as you can see here NO value is 0.1 and here it is 0.1. So in experiment 1 and 2 it is remaining same, and here it is in experiment 1 and 2 H2 value is doubling. So let's find out what happens with this. So this is constant now. So we will consider experiment 1 and experiment 2 for finding this order of reaction for H2. So let's find out. So let's solve this. So first we will find for the concentration of H2. So for concentration of H2, so we have to actually divide this value from experiment 2, higher value, with the lower value. So let's we will keep this in numerator. So 0.200 upon 0.1, so 00, so it will become 2. So concentration is coming as 2 here. Now the same thing we have to do for rate. Experiment 1 and experiment 2. So the second experiment we will take the value here, what we have done in scientific notation, 0.5. So let's take this. So 0.505 into 10 raised to minus 5 upon 0.253 into 10 raised to minus 5. So this is for rate. So for rate we will find out. So let's solve this. So I am getting the answer as 1.97. So 1.97 means it is equivalent to 2. So you can see it is equivalent to 2. So that means here 2. We got the value here as 2. Concentration value was doubled and rate also got doubled. So here you can see concentration is doubled as we got the value here as 2. So rate also got doubled. That means rate also got doubled. So we are getting the same. Whenever same number comes now, after dividing concentration and after dividing the rate, so it is called as first order reaction. We will see the that also table. So let's see the table. So here as you can see in for this we will find out. So concentration is doubling, so this value is doubling, that means into 2. So rate also doubles, so into 2. So this is the first order reaction. So it is first order with respect to H2. Okay, so it is first order with respect to H2. First order with respect to H2. Okay, with respect to H2. So first order with respect to H2. Okay, so now we got all the things. So now we can find the second part of these equations, because they have asked the rate equation for this. So let's see the second part. So write the rate expression for the reaction. So this is the second part. So rate expression we can write now easily as we got it. So rate expression is always given by K is the constant, and then NO, rate constant, and NO. For NO we found that it is order 2, so that's why we will write raised to 2. And for hydrogen we got the value as first order, so we will write here as 1. So here in this way, this is the rate expression for this equation. So now the further one, calculate the value of rate constant including its unit. So here we have to just substitute the values in this equation. This is the main equation where you will just substitute the values, but you have to consider from the same experiment, whatever you are considering. So we will consider from the experiment number 1. So experiment number 1 is this. So we will put all the values here from the experiment number 1 according to this, and we will find the answer. So here as you can see, so here R, we will write R equals to K, we want to find K. NO, so NO value we will find out. NO here is in the experiment number 1, it is 0.1. So right here 0.1, the whole square. Then here for H2 it is 0.1 only. Let's see the rate. So it is this 0.253 into 10 raised to minus 5. So we will write this value in place of the rate. So it is it, and we will write here this value 0.253 into 10 raised to minus 5 equals to K. So we will solve and we will find the K value. So this both will come in the denominator and this will go in the numerator. So 0.253 into 10 raised to minus 5 divided by 0.1 into 0.1. So we will solve this in our calculator, on our calculator, and we will see what the answer comes. So it is coming to 2.53 into 10 raised to minus 3. 2.53 into 10 raised to minus 3 is the answer for the value of rate constant. But the thing is that including the units. So for finding the units, now we have to just what we have to do? We have to substitute the values here of the whatever the units are there. So let's substitute the values. So rate they have given in mole per dm cube per second. So let's write this. In place of rate we will write mole per dm cube per second. So unit of this 0.1 means it is mole per dm cube square. So mole per dm cube whole square, and then this also mole per dm cube whole square. Mole per dm cube only because it is only one time. So mole per dm cube. So I will write on the next page this whole thing. So now this will go, this square will go, and this whole mole per dm cube will go, and then here what will remain here? 1 upon second. So this will remain 1 upon second, and this line, this same line, and then mole per dm cube. This mole and mole will become mole square, and this dm cube 3 and this dm cube 3 will become dm cube 6. Then it will become per dm cube 6. As you can see here, this means 1 upon second will come down. How it will come down? I will show you. So we will just put here 1, and this is the sign. This I will make it green color, this division sign. So here we will put division. We will just separate this 1 upon second. Instead of this green line, I will put division, and then mole square per dm cube upon 1. So this is the main thing. Now we will I will write the same thing here on the next page. Here I have written. So now division sign, where we will invert this, and this division will become multiplication. So as you can see, 1 upon second, then this I will change it to multiplication, and then this will invert. So 1 will go on the numerator, and mole per dm cube, mole square, this square, and dm cube 6 per dm cube is 6, dm cube 6 will come in the numerator. Now we have to take everything up. So second, if we want to put it into the numerator, so we will write inverse. So second inverse, and mole is having positive value here, you can say plus, so this also will become minus. When we will put minus, mole minus 2, and then dm cube per dm cube, it is per dm cube means when we will take it in the numerator, then it will become, so per dm cube we will remove this per, and we will put minus sign here. dm6, okay, so this I have removed the minus sign, and per I have removed per sign, so I will put here minus. Now this whole thing I am taking this also dm cube in the numerator, so this will become positive value. dm6 will come up, so it will become just when you are putting in the numerator the sign changes, so it will become dm, instead of minus 6 it will become plus 6. So this is the unit. So but always it is considered, we will write this value first, mole minus 2, then here we can write dm6, and time always is written at last, so that's why second inverse. So this is the unit of this. So D part, let's do the D part. And D part, as you can see, they have given these steps. So intermediates are found: fast step, slow step, and then fast step. So you can see this slow step. So slowest step is always rate determining step. So as you can see, NO is involved here. In the main equation, check here. So as you can see here, hydrogen, 2 hydrogen is there, and 2 NO is there. So this hydrogen and NO, so you can see 1 NO is reacting here, and here 1 H2 is reacting to form an intermediate. So this is the intermediate. Okay, so here the first step is fast, means this is fast. So but the second step, the intermediate formed, is reacting with the second NO, because 1 NO got reacted with this part. Now 1 NO is remaining, so it got reacted with the second step, slow step. So it is reacting, that intermediate X is reacting with this. So Y is formed. So always the slowest step is the rate determining step. You can say that mechanism agrees with the experimental rate expression. Experimental rate expression we got now, so it is agreeing because NO in the experimental rate. So you can see here. So I have written the rate expression. So as you can see, this is agreeing with this, and then H2. So here H2 is there, and intermediate is formed. So that's why it is agreeing with our rate expression. So let's see the E part. So in E part, they have asked, explain why single step mechanism is unlikely for the reaction of this kind. So why it is there? So as you can see, the reactant, this is one reactant and this is two reactant. So here 2 molecules of NO and 2 molecules of H2. So 4 molecules are involved. Wherever 4 molecules are involved now, so it is very difficult that it can occur in single step. So that's why it will be in multiple steps. So that's why we can write that it cannot happen in single step, because 4 molecules cannot collide at the same time with each other. So it is very unlikely that 4 molecules will collide with each other. So this we have done. Here they have given, they have asked the part F of the question. Deduce how initial rate of the formation of water compares with that of the N2 in experiment 1. Explain your answer. So for that we have to see this experimental data. So this equation we have to see. As you can see in this equation, when 2 moles of H2O, so here 2 moles of H2O is there now. So this is 2 moles of H2O forms 1 mole, here 1 mole of nitrogen. So 1 mole of nitrogen. So 2 moles of H2O and 1 mole of nitrogen is formed. So in this way it is formed. So H2O formation is double that of the N2. So we can say the formation of H2O is 2 times that of the N2 because it is double 2 mole of H2O formed. So we can say in this way. So rate of formation of H2O equals to 2 into rate of N2. So that's it. We have solved this question. Now